Welcome to today's Explainer. We spend a ton of time talking about how artificial intelligence is changing what happens on our screens. But today, we're taking a massive leap into the physical world. We're looking at how AI is literally shaping the buildings we live, work, and learn in. And honestly, it is absolutely fascinating.
So here's a question to keep in mind as we go through today's analysis. What actually happens when you let an artificial intelligence design a middle school in one of the world's absolute harshest climates? We're talking about Tripoli, Libya, a place where the hot, dry environment is the ultimate stress test for modern architecture. Can an algorithm really build a better classroom?
Okay, let's dive into this. Here is our roadmap for today. 1. AI meets architectural design. 2. The extreme climate challenge. 3. The digital tool belt. 4. Case study, Tripoli School. 5. Before and after AI. And 6. The future of architecture. Section 1. AI meets architectural design. The shift to data-driven buildings. Let's start with a massive paradigm shift. For a really long time, architectural design relied heavily on human intuition to balance aesthetics with structural needs. But today, the driving force is generative design. Think of it as a digital co-architect. Instead of a human drawing a single design and just hoping it works, you give the AI the rules, the parameters. The algorithms then automatically produce and test these incredibly complex forms. It can rapidly explore thousands of environmentally responsive solutions in a fraction of the time it takes a human designer to draft just one. I absolutely love this quote from the research because it perfectly highlights the stakes. The application of AI in architecture is not merely an efficiency gain, but a fundamental shift towards more data-driven, environmentally responsive design practices. Right? This isn't just about saving an architecture firm time or money. It's about fundamentally designing buildings that actually work in harmony with the planet. Moving to Section 2, the extreme climate challenge, building for Tripoli's heat. Enter the villain of our explainer story. Tripoli has incredibly hot and dry environmental conditions combined with intense seasonal solar radiation. I mean, if you build a standard glass and steel modern box out there, it essentially becomes an oven. You desperately need passive design strategies, things like strategic shading and natural airflow. The problem is, traditional design methods are frequently failing to achieve optimal energy efficiency and thermal comfort in these extremes. All right, Section 3, the digital tool belt, meet your AI co-architects. So if the traditional methods are coming up short, how are researchers fixing it? Well, the software ecosystem they use integrates climate data in a really clever way. You have Rhino, which handles the complex 3D geometry. Inside Rhino is Grasshopper, a visual programming tool for parametric design. But the real magic happens when you plug in Ladybug and Honeybee. Ladybug pulls in the actual historical weather data for a specific location, while Honeybee runs incredibly detailed environmental simulations for things like energy modeling and daylight. Here's how that process flows chronologically. First, the team imports the local weather data directly from the meteorological station right there in Tripoli. Second, they generate the 3D parametric models. Third, they run those intense environmental simulations. And finally, they let the algorithms optimize the design variables based on how the building performed in the simulation. The weather data literally dictates the shape of the building.
Section 4. Case Study, Tripoli School, the Schools of the Future Initiative.
Let's pull this out of the theoretical and into reality. This isn't just an abstract data exercise, it's a real-world project. We're looking at a proposed 12-classroom preparatory school, which is part of Libya's Schools of the Future Initiative under their Return of Life plan. These are future learning environments for real middle schoolers. The entire goal is to ensure this building is actually comfortable for them before a single brick is even laid. To pull this off without melting their computers, the researchers were super smart with their computing power. Instead of simulating every square inch of the entire complex, they targeted a floor plan that isolated specific classrooms, like rooms 3 and 6, to run highly detailed environmental stress tests for daylighting and ventilation. And this brilliantly illustrates exactly what the AI actually sees. It generates a 3D thermal heat map to visualize the thermal performance and heat loads inside those specific classrooms. It shows the AI exactly where the sun is baking the room and where the air is stagnating. It basically allows the algorithm to pinpoint the exact problems with the human-made baseline design. Once those problems were identified, the researchers unleashed the generative algorithms, giving the AI control over specific physical variables. The AI was allowed to tweak the building's orientation, change the window-to-wall ratio. Actually, wait, it wasn't just tweaking. It was iterating through countless variations of shading depth, wall thickness, and even material properties to find the absolute perfect configuration.
Section 5. Before and after AI, the data reveal.
All right, moment of truth. Did the digital co-architect actually build a better school? These numbers are literally off the charts. In the baseline model designed by traditional methods, daylighting was insufficient, sitting at around 230 to 280 lux. The AI bumped that up to a very good 320 to 380 lux. Ventilation? It doubled, going from 3 air changes per hour to 6 to 8. But look at thermal comfort and energy. Thermal comfort jumped from just 35% of occupied hours to a massive 62%, and the energy usage plummeted from 92 kilowatt hours per square meter down to just 64.
Just to put that comfort metric into perspective for a second, the AI nearly doubled the amount of time these students will spend in a comfortable temperature range. That means drastically less reliance on mechanical air conditioning and a much better environment for these kids to actually focus and learn, simply by letting an algorithm reshape the building.
But here is the absolute kicker: 30%. Overall, the AI achieved a 30% reduction in annual energy consumption for this school. That is a massive victory for sustainability and, frankly, a massive cost saving over the entire lifetime of the building.
And how exactly did it pull this off? Well, there's no magic here, just highly optimized physics. The AI simply reoriented the building to better catch the wind and avoid the harshest sun. It optimized the exact locations of the windows, added strategic shading devices of the perfect depth, and swapped in thermally efficient materials. It essentially took traditional passive design wisdom and perfected it mathematically.
Section 6. The future of architecture: sustainable and resilient. Zooming out from Tripoli for a second, the big takeaway here is that this technology significantly reduces our reliance on mechanical cooling. Ironically, AI is breathing new life into ancient, traditional passive design wisdom by applying hyper-fast computational optimization to it. It rapidly accelerates how fast we can find high-performing solutions. And while the computing power required is intense, these tools are helping to democratize sustainable design everywhere, proving that AI doesn't replace the architect, it acts as an essential, high-powered partner.
I want to leave you with this thought as we wrap up today's explainer. The researchers noted that the very next step could be integrating real-time sensor data with these AI models. So as our global climates become more and more extreme, will self-optimizing buildings, structures that continuously adapt their own operational strategies based on real-time weather and human behavior, become the new standard for how we survive and thrive? It's a wildly fascinating future to keep your eye on. Thanks so much for learning with